The following teacher development program is brought to you by the MultiChoice Africa Foundation.
Are you sure you want to walk? I mean, it's just an hour before the math literacy workshop starts.
Oh, come on, Braamfontein's around the corner, right there. Come.
Are you saying Braamfontein is there? Oh, man, I can't see it.
That's because we're still low on the copy. As soon as we go higher up, it'll be there. I guarantee it. This way.
Come. Come. Ooh.
Wow.
Hey, that's Ponte Seat, yeah? That tall building next to the Hillbrow Tower.
Yeah.
Yeah. But it's flat, man. It's round, you know. It's famous for being round.
Well, that's because our point of view makes it look flat. We see in perspective. So when you look at something far away, you lose depth and you actually lose the detail in color. But if you move forward or you change the angle, you'll see it's round.
I know. I've been there for a party. You know, when you're standing on top, it's like a toilet roll.
Well, it would be round if you're coming from the top, of course. And if you get a helicopter ride, you'll get a great bird's eye view. That's the closest I'll ever get to that part of town. Hassan, to the other side. Check.
What's that? Wait, I'll hold you.
Oh.
Steady. There we go. That's it. Brixton Tower. Thandi, come look over here. Brixton Tower. First I couldn't see it, but now I can see it completely. How do you explain that?
That's because your line of sight changes as you walk up the hill. And as you know, the line of sight determines what you can see. So as you move further up the hill, your line of sight changed to include more and more of the tower. And the angle of your line of sight became larger.
We also couldn't see sports fields there, you know. But now we can see them. This is surprising, eh?
Exactly what I mean. Things get revealed or hidden depending on the line of sight.
That massive building there is only 2.5 centimeters from here. I bet you can't do that with math.
Actually, I can. It's because of perspective, and it's obvious. Things get smaller and smaller the further away you move. And in maths, we talk about the vanishing point on the horizon. And that is, things get smaller and eventually disappear the further away you move. And that's the vanishing point.
Talking about vanishing, let's vanish. Let's go. Let's go. Yeah.
Lebogang, are you sure this is right? Braamfontein's over there. Where are you taking us?
Hey, man, this map is confusing me.
Man, just check your map properly. Give me that.
No, but wait, man, I just want to check something. Okay. If I look this way from Brixton Tower to Hillbrow Towers, on my sight line is... So Braamfontein should be over there. Wow. And look at this tower. You can see the curve and how high it is. Now, if I had to draw it from where we were versus here, it would look totally different.
Of course. That's why architects draw buildings from all different angles, so you have the whole picture. Their drawings are called elevations, which are different views from different sides. It's their specialty.
We visited Kate Otten Architects, where we spoke to Adele de Lange about how elevations are drawn.
Basically, in architecture, we don't speak of a top elevation, but it's called a plan. And what you are doing, you actually see the building from above it, floating at 1 meter high. If I were to cut this building all the way down to 1 meter above the ground level, this is the kind of thing that we would be seeing. It would be actually walls that are cut from, you're looking down into the wall, you're looking down onto the floor. So everything is in what we call section, and that is a plan. The whole point of the drawing is to make other people understand what our intention of building is. The first reason is for the client to understand what kind of building they're going to get. And the spatial understanding of how a building works has to be simplified in drawings. So we use mathematical little geometries basically to explain what a real thing is going to be like. And then the second thing that's very important is for the builder to understand what he's actually going to do. So we use different scales of a drawing to explain various parts and various details. If you want to explain something very complicated, it has to be a very big scale, almost real life. But when you just want to show someone what a building looks like, it becomes very small, so it's just an impression of what you'll actually see when you're standing outside the building.
There's lots of mathematics in architecture. For example, calculating floor surface area. Often technology is used, but you still need to understand the principles.
We draw on computers these days, but in the olden days they had to use rulers and work out the angles according to mathematical relationships, how the lines would work. We calculate the distances with you will always also use maths. If you think about this is the real distance of 3.5 meters. Now we make that smaller. We have to divide that by 100 units so that it becomes at a scale of 1/100. So we're always dividing, multiplying, depending on how big we make this drawing and how much information we want to put on there. For us as architects, we actually forget how much we use maths. And everything is geometry. The way the angle of a line to make the angle of a roof is a line that you're drawing at a specific angle. That's geometries. To set something apart, we use distance. One line is a set distance away from something else. You've got to measure that, and you've got to calculate how big a building is, how big a room is. All of that has got to do with geometries, because also certain geometries don't work. If a room is 500 millimeters, if it's very small, a person won't fit in that. We measure the size of the room to make sure that someone will fit in there and whether they'll actually be able to use the space for what it's intended for. And that's all geometries of how things work. We find that in our field that we work in, people struggle to understand the relationships between what they're seeing on a page and what they're actually seeing in real life. And it's also simple. And using maths to explain that is actually such a good idea, and especially for young people to get to understand how these things work, because you are going to have to deal with it for the rest of your life. You are going to buy a house, you are going to work in an office space, you're going to rent an office space, and you've got to understand how these spaces work. And if you see something on a plan, is it something that you'll enjoy?
Bloemfontein?
Yeah, the city looks different on the map. This is Hillbrow.
I know that.
Ah, there is Ponte City. You see, that's round for you. And this perspective thing is very interesting. Do they teach this in math literacy?
Yes. Mr. Joshi at SBSM Secondary does.
Mr. Shirish Joshi is teaching a maths literacy lesson on vision geometry. In simple terms, this means he's looking at the maths of how we see things. He's found an interesting view of a place the learners should be familiar with. This is the plan of their school, drawn by the architects who designed it. Shirish asked the learners to point out familiar places.
Particular room here. Can you tell me what is going on there?
It's the classes.
Which class would you think of that is
It's
placed
the
there?
preschool in Montessori.
Preschool and Montessori. Can you show me where's the electricity box in this plan?
Some of the learners find it tricky because they don't normally look at the school from this angle.
Yeah. Ah, thank you. Thank you. Tell me, if you wanted to view this entire structure at one go, where would you stand?
In a helicopter.
Thank you. Thank you. That's it. You could be in a helicopter, isn't it? Or you could be suspended in the mid-air. But well above the building, isn't it? It should be well above the building. So what type of view would you regard this as? Bird's eye.
Next, Shirish talks about plans and technical drawings. Technical drawings have to be very accurate as they're used in building and manufacturing of product. You have to be able to put several views together to see the object as a whole.
What do you think that is?
Gate.
Look at the structure just above that so-called gate.
Pillars, maybe a pillars of monuments of significance.
The so-called gates is actually the roof of these, the structure of this plan here.
Oh, so this is actually the roof of this. So it's the kind of like the garages that you get, and the roof is covering it that way. So this would most probably be the side view like that, and this would be the top view.
It's like a garden pagoda which you see from the side, and you'll notice the structures for the plants to grow along on top.
Shirish has asked the learners to bring various objects from home. They draw unusual views of these objects in their groups.
Let's start from my right.
Then it's time to guess.
It's a sharpener.
So it is a sharpener.
Right, I think that deserves a good one. Right.
Is it a water bottle?
No.
Top view of a pepper grinder.
Ah, that's a nice one.
These different views or elevations are good for designers and manufacturers, but ordinary people struggle to visualize what the final product will look like. If you want someone to be able to see what your building or product will look like, you need to draw like the eye sees. You need to make a perspective drawing. Shirish hands out a photograph and asks the learners to measure different people in the photograph.
Take your ruler and measure the persons that is closest to you in that picture.
14.5 centimeters.
I want you to take that ruler and I want you to now measure the height of that person that is between the two persons as shown in this picture here. What's that? 5. Now, let's look at something clearly. If I look at these two persons, do you think the person in the background, that person that you measured, is smaller than the one in the front?
No.
But then why is his height smaller?
Because it's further away from the camera.
Photographs portray a picture like the eye sees it, in perspective. If we want to draw a picture that looks as realistic as a photograph, we need to follow the rules of perspective. Shirish spots a picture in the class that helps him explain further how this works.
Let's have a look at that Taj Mahal. Notice the two edges. And as they move further away from us, what do you notice?
So it gets narrower.
It gets narrower, thank you. But in reality, is that getting narrower?
No.
Why not?
Because it's further from the viewer.
Yes, it's further away. That's why it seems as if those lines are eventually going to meet. But in reality, you notice the two edges of the lake are parallel.
As anyone who knows maths knows, parallel lines never converge. But when we look at a picture in perspective, it looks like they do. This is because all objects in a perspective drawing tend to converge in a vanishing point as they get further away from the viewer.
Eventually, what is happening? It's getting smaller and smaller. And what happens eventually? What do you think happens?
It vanishes.
You notice there is a specific point where they seem to disappear. And now that's basically called my vanishing point.
Shirish explains how the position of the vanishing point will change as the line of sight of the viewer changes.
You notice different observers have viewed the same object, but their vanishing points are different. This man over here, his line of sight was on this direction here, and the vanishing point was somewhere around here. Whereas this child here looked at the vanishing point from a different angle and noticed her vanishing point was somewhere around here. Whereas our last observer looked at the same object and they found the vanishing point somewhere around here. The important thing is to know that the vanishing point does not remain fixed. It depends on where the observer is standing. That is important.
Shirish gives the learners blocks to draw in perspective. They have to create a horizon and a vanishing point to help them create their drawings.
I want you to follow those steps and complete your perspective drawing for one block.
A tower, and now I drew the side view of it, how I see the side view and where my vanishing points, so where I see it and where the vanishing points will come. This is how it will look. Your side view and your vanishing points, these two, because as the further away you move, it will come together. You're blending these 2 points.
At the end of the lesson, the learners have a clear understanding of the difference between perspective drawings and drawings of different elevations or views.
I think the lesson was very interesting, especially if people who are interested in doing architecture and manufacturing things in factories and stuff, they can use ideas to build things, and it's very, very interesting.
Today's lesson I felt was quite spectacular, and to those who are going to, in the future, become architects, it really gives us a piece of advice and how we should go about doing things. And this lesson taught us about different drawings and how we should look at an object in a different angle and finishing points and all. So it was quite a good lesson, and learned a lot from it.
Joburg looks exactly like on the map. From where we're standing on top of the copy and even where we stopped, we couldn't see half of this. Like you said, there's so much exposed and there's so much hidden, depending on where you're looking from.
Am I winning you over to the math literacy team yet?
I'm gonna come. Let's go to the math literacy workshop.
Yeah.
Right.